All right, so we're looking at lesson 59 today. Experimental data, simultaneous equations with fractions and decimals, and then also rectangular form to polar form. All right, so, okay. All right. So looking at an example dealing with experimental data. No, do not write all of this. So the data graph below came from an experiment about bronze and copper. The line represented by the data points has been estimated, and they're going to tell you that in every problem, that that's an estimated line. What you need to write the equation of this line that gives bronze as a function of copper. Because that's what we're going to do. We're going to write an equation that gives bronze as a function of copper. And then it also tells you that the two scales are different. You don't have to write that sentence. All right, so the little dots that are circled are our data points. Do you see how some of them are on the line? Some of them are close, some of them are not exactly on the line? We don't really care about the data points right now. We only want to find the equation of that black line that they drew in for us. So how can we find the equation of a line? We need to find the slope. So we need 2 points. Do you see how this is a good point because it goes through? Okay. This looks like a good point, but these aren't far enough apart. You need to have your points further apart. So if you keep coming up, do you see how there's another point up here? Okay. So what is this point right there? 5, 5. So we're going to do 5, 5. And what is our other point? 15, 40. Do you see how they are on the line? They're not necessarily the circled points. Okay, so we're going to use our slope formula. y2 minus y1 over x2 minus x1. What is our y2? Minus what? Over 15 minus 5. So what do you get there? 35 over 10, which is 7 over 2, if you divide both by 5. You'll see where the slope comes from? So that's the first part. Now we have to find an equation. Well, if we have a slope, how do we find an equation? Okay? What do you want to plug in for your y? 5 equals, what's our m? What's our x? And then plus b. Any questions on that part? Okay, so 5 equals 35 over 2 plus b. So what would your b equal? Do you agree? Okay, what would be our equation? All right. However, it said write it that gives bronze as a function of copper. This is my y-axis, right? And this is bronze. So instead of y, I'm going to write bronze. I'm not going to write out the whole thing. just going to write a B for bronze. What is my x-axis? So I'm going to make it a C. That is one part. And then also, since we're dealing with science, you don't want to have fractions. In science, you want to have decimals. So what is 7 divided by 2? 3.5. And 25 divided by 2? 12.5. And so you don't leave it here. This is your actual answer. Well, you got to know how to do the math part of it in science. So we practice it here so that when you get to science, it's not so hard. Okay, let's look at another example. Write an equation that expresses nitrogen as a function of sulfur. It tells you to note the extreme differences in the horizontal and vertical scales, but you'll figure that out when you actually start finding your points. What do you mean? You got to make some points. So here's a good point. That one's too close. You don't want them that close to each other. So let's come over here some. Do you see a good point? There's not a good point, so we need to just pick one and estimate it. Okay, 40 and 6.5. All right, so that first one is 10 what? Okay, and then y'all said 40 or 30? 40 and 6.5. That's a pretty close estimation. Go with me so far? What is step 1? Slope. Okay, so what would we do? M equals. Yeah. No, you were saying it. 6.5. Uh-huh. Okay. So what is 6.5 minus 1? Over. Which is. Yeah. And that doesn't reduce. 11 over 60. 5.5 times 2 is 11. So 30 times 2 is 60. So that's our slope. Now what do we do? Which point do y'all want to use? The first one. 1 equals 11 over 60 times 10 plus b. Yeah, we multiplied them both by 2 because we don't have a decimal and a fraction. You need either a decimal or a fraction. So we got rid of our decimal. So 1 equals 110 over 60 plus b. It is going to be a negative. What is it? Negative what? That's right. So your equation is going to be y equals 11 over 60 x minus 5 over 6. But we need to make them into nitrogen and sulfur and also change them into decimals. So what is my y going to become? N? Okay. S. And then minus. Okay. I just do. You're silly. I mean, I'm not going to count off if you don't. The book has 0.8 and not 0.83, but were we pretty close? Would that be acceptable? Mm-hmm. So if you put it into a decimal, you can easily tell whether your answer is close to the books or not. Y'all see how that works? Okay. Just ask me if you're wondering if this will be acceptable or not. No. On your homework, like when you're working it, ask like, would you accept this? This was the answer, and this is what I got. It depends on what the numbers are. Because these are pretty small numbers, so you shouldn't have a big difference. But if the scales were like by 100, then it would be like it would make sense to have a bigger difference. So it just depends on the problem. Okay, so that's the first part. Now we're moving on to equations with fractions and decimals. One of them has a fraction, one of them has the decimals. Yeah. We're going to change them because we don't like dealing with fractions and decimals. We're going to change them to whole numbers. So how do we get rid of fractions? Multiply by, which would be what? Okay, so what would x over 2 become? Okay, 5x plus 6y
Teachers, pardon the interruption. All soccer players going to Pine Bowl need to report to the gym lobby. Teachers, you received a roster of the students. Thank you.
Okay, so that's the first equation. How do we get rid of the decimals? Multiply by 100. We're going to move each decimal place 2 places. So that would be 6x minus 2, 20. Why 20? Because you got to move it 2 places. And then equals what? That. Does that look kind of like what we've done before? Now what? Elimination is going to be better. Okay, multiply by -6. And multiply this one by what? A 5. So y'all are wanting to eliminate your x. Because those are going to be smaller numbers. Okay, so you would have, for your first equation, negative 30x minus 36y. Okay. 30x minus 100y. Any questions to that part? Now what? Combine them. What happens to your x's? Okay. What about your y? Negative 136y. Then what? Divide by negative 136. You get -4. Okay, so you can plug it into the original one, or you can plug it in up here. Either one of these two. That's fine too. Which one do you want to plug it in? Okay, so 5x plus 6y equals -4. 5x plus 6 times negative 4 equals negative 4. So 5x minus 24 equals negative 4. So 5x equals 20. So x would be 4. So how do I write my answer? As an ordered pair. You all see how that works? So basically what you're adding to this is changing it into these two, and from there it works just like you've done before. What? Alright, now we're going to go from rectangular into polar. You've gone from polar into rectangular. What is polar form? Okay. Something like that? I don't remember what lesson it was, but it was maybe 2 or 3 weeks ago. 2 at 50 degrees. Here's what lesson? Alright, so how am I going to graph negative 5r minus 3u? So left 5, down 3. And that's my point. Y'all see how that works so far? Okay, so what we need to find, what we need to find is our hypotenuse, and we need to find this angle. In the past, they gave you the hypotenuse and angle, and you had to find the 5 and the 3 part. We're going to do what? Yeah, what's it called? Yeah, you're going to do that to find your h, because it's a right triangle. So what is 3 squared? What is 5 squared? So h squared equals 34. So h equals the square root of 34, which is what? I don't know what that is though. 5.83. You can leave it as either one. They put both in the book actually. So you could do either one. Okay, so now we need to figure out this angle. Sine, cosine, or tangent. Which one would relate only using 3 and 5? Okay, what is the tangent of this angle? Tangent is 3 over 5. You do tangent inverse of 3 over 5. Did y'all get that? Or is it 9.6? Or is it 9.6? That's what I thought. They round it to the whole number, so if you want to put 31, that's fine. You can round it to the whole number. Once you get to your junior year, they'll leave it 30.96, but if you want to go around right now, that's fine. Do y'all see how to get the hypotenuse and the angle? Okay, so when we write our answer, what number goes first? So our angle, where do we start when we measure the angles? First quadrant, and so we're going to go which direction? Okay, and we're going to stop here. That angle is obviously not 31 degrees. This part of it is 31. Plus what? Why 180? This part is 180, and then we got to go the other 31 degrees. So what is that? Yep, because this part down here is 31 degrees, right here. And so what is it? 211. And so that is your answer. So now we are going backwards. We had been just going from polar into rectangular. Now we're going the other direction. Now see how that works? You start here and get to that. Yeah, you start with the polar, and then you go into the 5R and the 3U. Okay, so let's try a practice problem. Yeah, you want to go further up. But yeah, this would be an okay point. So where else would be a good point?
35.
Yeah, those two would be good. Now do you see how there's a big difference between them? Fibonacci number looks really big, right? Is this the origin right here? Why not? It's going by ones, and so it's only showing you to 31, right? So do we have a long way to go this way before we get to the origin? So we're going to be like way far down before we get to the origin. So that's why it looks like it may not be right, but it actually is because of the way they put the graph. The book has graph. Is your answer acceptable? They're off by 5, but if you look at 80 to 75, is that really a big difference? A big difference going from 2200 to 2350? Not really. So that would be acceptable. But if the book had given you 22 and you had 200 and something, then that would be a bigger difference. Do you see how that works? Okay, so let's look at another example. Did someone leave the right hand?
Oh,
Yes, I have.
I don't like this kid thing.
I just want to help Yeah. Okay, so let's look at another one. See if you can convert this one into polar form. Except what?
1, 2, 3,